This is a tutorial about ionic bonding with polyatomic ions. Okay, so let's remember a few things about ionic bonding. Ionic bonding is between metals and nonmetals, right? So here are my metals and here are my nonmetals. Okay, with that being said, we also can have ionic bonding with metals and polyatomic ions as my nonmetals. So what are polyatomic ions? Well, let's take a look here at a list that I've compiled. Here are some popular polyatomic ions that you have to memorize. There are many more, but you only have to memorize these 8 seen here. Might be a good time to pause the video, write them down, and have them memorized. So, a polyatomic ion, poly means many, atomic means atoms, are many atoms bonded together that have an overall charge. So this is a little different than a neutral compound. I like to call this a cluster of atoms with a charge. So an example would be ammonium, not to be confused with ammonia, ammonium. Ammonium is 1 nitrogen with 4 hydrogens bonded that has an overall positive charge on it. So notice polyatomic ions, meaning ions with a charge. There is a charge left over. We like to think of them as a cluster, as a bundle that comes together. Don't separate them out. Keep them together as a cluster. Look at them as one whole thing. One thing that has a charge on it. Keep them together. So we've got all these different types right here. And these are the ones you have to memorize. Okay, so let's take a look at some examples. Let's look at when a metal bonds with one of these. And in my first example, I've picked the metal calcium bonding with nitrate. Not to be confused with nitride. Nitride is nitrogen as an anion. Nitrate, let's take a look. There it is, nitrate, ends in ate, is a polyatomic ion. Okay, so how am I going to write a formula for this? Well, same rules apply, and that is first turn these into ions. Anytime we have ionic bonding, you want to turn things into ions. So I have calcium. So I look on my periodic table, and I find calcium. And if you remember, calcium is in my 2+ column, right underneath magnesium. So calcium has a charge of 2+. Good, some old things we know. Nitrate, well, I have to look on my polyatomic ions to find nitrate. Capital N, capital O, little 3 minus. Write that exactly how you see it. Capital N, capital O, 3 with a minus. Okay, remember, the goal is still the same, and that is let's neutralize these. So nothing has changed in that. So how many of these clusters or bundles of nitrate do I need to balance out the calcium? Hopefully you said I need 2 of these. -1 -1 gives me -2 to balance out the 2+ on this side. Remember, the goal is to make 0. Same thing applies, which makes this easy. How do I write this overall formula? Well, let's take a look here now. I need 1 Ca, 1 Ca. How many of these NO3s do I need? I need 2 of them. So watch. N, O, capital N, capital O. Put the little 3 there. It just belongs to it. It's part of it. And I need 2 of these. I need to put this in parentheses to say I want 2 of these NO3s. All right. Let's try another example. Let's go with ammonium nitride. Ammonium nitride. Okay, ammonium. If you remember, ammonium is a polyatomic ion. It's one of the ones you have to memorize. NH4. Nitride is just nitrogen from the periodic table. Not to be confused with nitrate or nitrite, which is a polyatomic ion, okay? All right, nitride is from the periodic table. So let's bring back the sheet and copy down ammonium. Capital N, capital H, little 4, just a part of it, a plus charge. Okay. Nitride. Let's look back to my periodic table. Find nitrogen, 3 minus charge. I'm going to write that here. Nitrogen, 3 minus charge. Okay? Again, focus on the charges. Don't worry about all the extras. A positive and a 3 minus. Okay? Don't worry about that 4. That just belongs to this polyatomic ion. It is not part of the charge. The charge is plus. I need 3 of these. Plus, 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 plus 3 to balance out the 3 minus. So how do I write this name? Let's take a look here. Or this formula, I'm sorry, this formula. NH4, and how many did I need? I needed 1, 2, 3. So watch, I need to put this in parentheses to say I want 3 of all of that bundle, that package, and I just need 1 N. Notice, again, no charges because I've neutralized my charges out to 0. Okay, and let's try another example. Sodium hydroxide. All right, sodium is on my periodic table as a charge of plus. Hydroxide is a polyatomic ion seen here. OH minus. Well, positive 1 and negative 1 balance each other out. So I just need 1 of each. No parentheses needed. Okay? All right, let's move on to another one. How about magnesium hydroxide? Magnesium hydroxide. Let's find magnesium on the periodic table, and let's find hydroxide. Magnesium has a charge of 2 plus. Hydroxide, like we saw in the last example, is OH minus. Okay, now focus on the charges. Don't worry about the package here. I need 2 of these polyatomic ions to give me a minus 2 to balance out the 2 plus. How do I write this? 1 Mg, and I needed 2 of these. Now you have to be careful. You have to put them in parentheses because I want 2 of the OHs. If I just write this, this is wrong. Because this says I just have 2 hydrogens. This is wrong. I need 2 of the hydroxide groups. So I put in parentheses to say 2 of the entire polyatomic ion. Okay, now, what if I want to do the reverse? What if I give you the formula and ask you to write the name? Okay, this is easy. The names don't change at all. They keep the names that are seen on the periodic table and on the polyatomic ion sheet. So Na is sodium. NO3 I find here must have came from the nitrate ion, and I keep the ending. So sodium, nite, and again NO3, nitrate. No ending changes, it all stays the same. No ending changes. Polyatomic ions never change their ending. I get to copy it like I see it. Okay? All right, how about this one? Again, NH4 must have been ammonium. So, no name change. Ammonium. Okay, now, that was nitrogen, which is on the periodic table, and it's an anion. This one does get changed to nitride, ammonium nitride. Notice in this example, the polyatomic ion came first, whereas in our last example, it came second. Wherever the polyatomic ion is, it doesn't matter. The name stays the same for the polyatomic ion. Because the polyatomic ion is not second, this one's a little different. This is ammonium nitride. All right, and let's try one more. Here's an example where now the polyatomic ion's in the back, all right, as the anion. And let's see what we have here. So in this example, I have sodium from the periodic table. The metal keeps its name. And now I have CO3. Capital, capital. Capital, capital, that must have been carbonate. Sodium carbonate. I never change the endings of the polyatomic ions. So some good things to note are most of the polyatomic ions, not all, most end in ate, ate, ite, ate, ite, ate. Do you notice that? So I kind of wrote this little note, most, not all, end in ate or ite. Kind of helps you know if you're dealing with a polyatomic ion. Again, these can be confusing, so that's why we memorize them. You don't want to look at something and call the sodium nitrogen oxide. Notice two capitals by each other is a polyatomic ion, right? Two capitals by each other. That's the end of the video.